Okay, so now that we have the volume where we left off last video, we can now find the mass because we have the density and the volume. So if we write down our density here, it's 1.5 grams per centimeters cubed, right? If we multiply the volume and the density as it's written now, my units aren't going to cancel out again. I'm in feet cubed and the bottom of my density is centimeters cubed, so they're not going to cancel. So what I have to do again is I have to convert my volume into the right unit, which is centimeters cubed. So I'm going to take my feet cubed and I am going to convert that into centimeters cubed. And here's where a lot of people have difficulty converting units, and it has to do when units have a higher power than 1. So I'm going to teach you guys a simple way. I'm going to approach this as if my feet just had a power of 1. So I need to go from feet to centimeters. So I am going to go from feet to inches, inches to centimeters. So I know that in 1 foot, there's 12 inches, right? And I know that in 1 inch, there's 2.54 centimeters, right? So those are my conversion factors that I need, but I also need to worry about my power of my units. So that's very simple. What I gotta do is if I want my units to be of a higher power, I have to cube the whole thing. And I have to cube both my conversion factors because in order for my units to cancel is what I'm trying to say. So all I'm doing is I'm cubing the whole entire number. So I'm cubing 12 over 1, which happens to be 12 cubed is 1,728 over 1. And same thing with 2.54, I'm cubing the whole thing. So if I do this in my calculator, 10 times 12 cubed times 2.54 cubed, I get my volume in centimeters cubed, which happens to be 283,168.46, and then so on and so forth, right? And that's in centimeters cubed, okay? So that's my answer in centimeters cubed. I could now use my density, which is in grams per centimeters cubed, and multiply these two and see what I get. So if I multiply these two, my units cancel out now because they're both in centimeters cubed and one's on the top and one's on the bottom, so they're going to cancel. So if I multiply 2.83, that whole big number, by 1.5, I get an even bigger number, okay? And this number, I'm going to put in scientific notation because it's fairly big. And again, 2 sig figs because all my other measurements or numbers in this question have 2 sig figs. So this is going to be 4.2 times 10 to the 6 grams, okay? Now, that is my answer in grams. But the question is asking for the mass in kilograms. So I have to take one more additional step and turn my grams into kilograms. And that's very straightforward. In 1 kilogram, there's 1,000 grams because a kilogram is bigger. So I have to divide this big number by 1,000, and it turns out I get 420 kilograms of sand. So my final answer for this question is 420 kilograms. Okay? So that's the way I did this problem. I hope this made sense. Again, it's important to have the right units, and it's important for the units to cancel out. So just take this question very, very slowly and make sure you guys have the right units, okay? Again, let's go to number 7. Okay. So number 7 says, a cylindrical glass tube, 15 centimeters in length, is filled with ethanol. The mass of ethanol needed to fill the tube is found to be 9.64 grams. Calculate the inner diameter of the tube in centimeters if the density of ethanol is 0.789 grams per milliliter. Okay, so this sounds like a mouthful, right? We're dealing with some cylinder, and we're asked to find the mass Sorry, we're asked to find the diameter of the tube in centimeters. Okay. So the first thing that we're going to do is I'm going to draw a picture. So I have this cylindrical glass tube, right? Some cylinder with some height. Turns out the height here happens to be 15 centimeters, right? Okay. So 15 centimeters, and the mass inside the tube is found to be 9.64 grams. Okay. And we're asked to calculate the diameter. So we care about the circular part of the cylinder. We're asked to find the diameter of the cylinder. So we know that diameter is twice the radius, this being the radius. So we know the diameter is just 2 times the radius. So D equals 2R. So somehow we have to find the diameter. So how do we find the diameter of a cylinder? Well, we first need to know the volume of the cylinder, right? So if we have the volume of a cylinder, the formula for it, it turns out the volume of the cylinder is pi r squared h. And you guys are probably wondering, well, why do I need the formula for volume of the cylinder? Again, we're given a density and we're given a mass, okay? So whenever you're given a density and a mass, you can actually find the volume, okay? And the way that we're going to do that is we start with the mass, 9.64 grams, and we're going to multiply by the density just to show you guys what I mean. So if I were just to multiply the mass times the density as it's written in grams per milliliters, my units wouldn't cancel. So what I have to do with the density is flip the density. So instead of writing 0.789 on top, I'm going to write down the bottom. I'm just taking the reciprocal of it. So it turns out that if I flip my density, I could find the volume using the mass. So I'm going to write down here, mass times volume over mass, which is just the density flipped, equals the volume. And this is where the volume of the cylinder comes into play. We need the formula because the only way to find the diameter is if we correlate it with the variable r. We know that the diameter is 2 times r. So the first thing we have to do is find the radius of this cylinder, okay? So just by doing some algebra, I know that my radius is going to be r equals the square root of v over pi h, right? So all we have to do is plug in the volume, take the square root of the volume and divide that by pi h. So we could easily find the volume now because we have the mass and we have the density. So if I do the calculation here, I get 9.64 times 1 over 0.789. I happen to get 12.218. And this is in milliliters, okay? And it wants to we need to calculate the diameter in centimeters. Okay. So I'm going to convert my milliliters into centimeters cubed. And I'm going to do that here at the bottom. So 12.218 milliliters into centimeters cubed. And you'll see why in centimeters cubed. Because converting milliliters to centimeters cubed is very simple. It's a 1-to-1 relationship. So in 1 milliliter, there's also 1 centimeter cubed. So that means I have the same amount of centimeters cubed. So it's 218 milliliter, okay? And you're probably wondering, well, centimeters. You're probably wondering, well, I still have a cubed unit. Yes, you do. And our objective is to find it in centimeters. But if we look at the formula, if we take the square root, that cubed power is going to be reduced to the power of 1, which is just centimeters. So we're actually on the right track. So now all we have to do is plug it in to our formula. So R is equal to the square root of the volume, which is 12.218 centimeters cubed, over pi, which is 3.14, times the height. Well, the height is already given in centimeters, so it's 15.0, right? So since we have centimeters on top and centimeters on the bottom, one of these centimeters is going to cancel and we'll be left with centimeters squared. But the square root is that's what's going to take care of the squared unit. It's going to reduce it back to a unit of 1, which is just centimeters. So if we plug this in our calculator, the radius is just the square root of that whole, the whole inside of the square root. So that's going to be 0.509 centimeters. So that's the radius. But we know that the question is asking us to find the diameter. The diameter is simply 2 times r. So diameter is 2 times r, which happens to be 2 times 0.509, which is 1.02. So the diameter happens to be 1.02 centimeters. And that is how we solve number 7. So again, this question is a little bit difficult because we're asked to remember the volume of a cylinder and how to relate that to our question. And that's simply by seeing that the volume has the variable r, and we know the diameter is 2 times r. So the first thing we have to do, or the one thing we have to realize, is we could find the answer by manipulating the volume formula of a cylinder. Okay, I hope that made sense.